Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll find the derivative of these functions using the quotient rule. Now the reason why we want to use quotient rule for these functions is because these are rational functions and they have the variable in the denominator. Now as per the quotient rule, so the setup is the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator over the square of the denominator. So let's start with our first function. H at x equals x over x plus 1. So the first step is, so prime of h at x equals, so we start with the derivative of the numerator. The numerator here is x, so the derivative of that is 1 times the denominator expression x plus 1 and minus the numerator expression, which is x times the derivative of the denominator, which will be 1 plus 0. So 1 is a constant, so that's why the derivative of 1 is 0 over the square of the denominator. So x plus 1 squared. Now we have to simplify the expression in the numerator. So first we distribute the 1 into the parentheses. So multiplication by 1 doesn't change anything. So we just get x plus 1. And in the next part we have to distribute x into the parentheses. Now in the parentheses we have 1 plus 0, which is 1. So x times 1 is just x over x plus 1 squared. Now we can simplify the expression in the numerator. So the x terms cancel each other out and we are left with 1 over x plus 1 squared. So this should be the final answer for the derivative of the function h at x using the quotient rule. So now we can find the derivative of the second function h at t. Now this is also a rational function, so it will be easy to use the quotient rule. So the first step is the prime of h at t. So we start with the derivative of the numerator. The numerator is 2t minus 3 and the derivative of that is 2 minus 0 times the denominator t plus 5 minus, now the numerator expression 2t minus 3 times the derivative of the denominator, which will be 1 plus 0 over the square of the denominator, t plus 5 squared. Now we can simplify the numerator expression, the prime of h at t. So 2 minus 0 is just 2, so we get 2 parenthesis t plus 5 minus, now in the second part 1 plus 0 is just 1, so that doesn't change the first parentheses, 2t minus 3 over t plus 5 squared. Now we can get rid of the parentheses in the numerator. So we distribute the 2 into the first parentheses. So we get 2t plus 10. And now in the second parentheses, we distribute the negative sign. And that changes the sign of all terms in the second parentheses. So we get negative 2t plus 3 over t plus 5 squared. Now we can combine like terms in the numerator. So 2t and negative 2t cancel each other out. So we are left with prime of h at t equals 13 over t plus 5 squared. So this should be the final answer for the derivative of the function h at t. Now we can find the derivative of the third function h at x equals x cubed over 2x squared minus 1. Now this is also a rational function, so we can use the quotient rule. So the first step is, so I can use a different color. So we'll start with the derivative of the numerator. So prime of h at x equals, so the derivative of x cubed is 3x squared times the denominator expression and then minus the numerator expression times the derivative of the denominator, which will be 4x minus 0 over the square of the denominator. Now we can simplify the numerator expression. So in the first parentheses, we can distribute 3x squared. So we multiply each term in the parentheses by 3x squared. So we get 6x exponent 4 minus 3x squared. And in the second part, we can distribute x cubed in the parentheses. So we'll multiply 4x by x cubed and then 0 by x cubed, but that won't change anything. So it's negative x cubed times 4x, so which will be negative 4x exponent 4. And the next term will be 0, so we can ignore it. And the denominator will stay the same. Now we can reduce the numerator expression. So we can combine like terms. So 6x4 and negative 4x4 are like terms. So we can do 6 minus 4, which is equal to 2. So we get 2x4 minus 3x squared over 2x squared minus 1 squared. So this should be the final answer for the derivative of the expression h at x. So these are the steps you have to keep in mind for using quotient rule to find the derivative of rational functions. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.